All right, so let's get going on today's class. So what we're going to do today is we're going to wrap up our look at the t-test. And this is going to be the final little piece that you need in order to know how to do each t-test, and more specifically, when to do each t-test. What is the situation where it's appropriate to use the 3 t-tests that we've looked at. So that's what we're going to end up doing today in the first part of class. But before we get to that, there we go, we're going to take up exam number 2. So again, if you haven't already, you can go to Canvas, you can download your graded exam, and I will be taking this up in class momentarily. And this is going to go pretty quick, so follow along, and hopefully it will illustrate anything that you might not have gotten correct. And we can't post this on my YouTube video, so let me just pause this. All right, so that was a take-up for exam number 2. Exam number 3 is on its way. So exam number 3 is going to take place next time we meet. So Monday, June 17th at 10 a.m. We're going to have our 3rd exam. And this is going to cover chapter 6, 8, and 9. Specifically, it's going to be hypothesis testing. So chapter 6 is going to be covered in the fact that we've learned what the comparison distribution is and where to find it, how to use it. That's how chapter 6 is going to be evaluated. You won't have to calculate comparison distributions by hand or do anything like that. It's going to be completely a hypothesis testing exam. So once again, it's a computational exam. It's going to be available in Canvas. There's going to be 8 questions-ish. I'm still finalizing. Once again, open book, which means open everything except communications with other people. So whatever you need to get these 3 hypothesis tests done, whatever you need to identify where the relevant information is for each hypothesis test in the SPSS output, how to set them up, how to identify them, whatever you need. Make yourself the notes, know where to get it, print those out for yourself if you like hard copies. Feel free to do that, take advantage of that. This is not a memorization course, this is a can you do statistics course. So to kind of help you gauge what you're going to be doing, I did put a template for the exam 3 questions in Canvas, and I'll just show you that right now. So for exam number 3, there we go right here. All right, so for exam number 3, this is what your questions are going to look like. So it's going to be more, get more detailed than that, but you're going to have a description, much like the hypothesis test. For exam number 2, you'll get a description of what the experiment is. You'll be told what type of test to do. So do a 2-tailed test with an alpha 0.05, do a 1-tailed test with an alpha 0.01, whatever the situation is. You will be given your raw scores. So there we have the raw scores for the 2 conditions in this question here, in this experiment. And then you'll be asked to fill in the following information for the hypothesis test. So for this hypothesis test, what is the null hypothesis? Delete whatever shouldn't be there so that you have your null hypothesis. What is the research hypothesis? For the comparison distribution, step 2, what are the degrees of freedom and what is the standard deviation of the comparison distribution? I will not ask you for the mean of the comparison distribution because most of the times the mean for the comparison distribution is 0. So I won't ask you for that, but you will be having to put in the degrees of freedom and the standard deviation or standard error. Step 3 is your comparison probability. So the exam will be based on comparing probabilities. So this is your critical probability, your cutoff probability. This is alpha. This is your Christmas in June gift. And I just want to make sure that you know that that alpha is the alpha I give you in the question. I don't want you second guessing yourself. I don't want you thinking that this is too easy maybe he's looking for something else, maybe I forgot to do something. It's my early Christmas gift to you. Alpha's alpha, don't touch alpha, but make sure that you put in that alpha for your comparison percentage. Then we have our samples probability, our p-value. That you get off of SPSS. If it's a two-tailed, you can read it straight off of SPSS. If it's a one-tailed, you take that percentage and you chop it in half. And then finally, you need to decide, based on those two percentages, do you accept or reject the null hypothesis, and do you accept or reject the research hypothesis? So that is what the exam is going to look like. Here's another example here. So be sure, as we review the hypothesis test on this final day, be sure that you know where to find that information in the SPSS output. Be sure that you know, and we'll review that one more time here, how to set up that information for input into SPSS, and that is going to be it for the exam. So it's all going to be hypothesis testing. It's all going to be asking for those particular pieces of information, and if you can do that 7 or 8-ish times, you get yourself 100% on exam number 3, and that'll be your best exam. All right, so any questions on exam 3 or what you can expect? All good? All right, and as usual, we're going to have a review session that's going to be taking place the day of the exam, but in the first part of class, beginning at 9 a.m. So once again, this is an open review session. It's going to be student-driven. Bring your questions, bring the things that you want to see. And also, because it's student-driven, it's also optional. So if you decide to come here and ask questions, that's great. I'll be here to answer them. If you decide that you can prepare better, you can use that hour better on your own, feel free to do that as well. We will be starting the exam 10. We'll try to start it right at 10, but 10-ish depending upon the review session. But that is there, and it's going to be available on that Monday. All right, so now let us wrap up our look at t-tests by finding out how it is that we decide which t-test to actually do when we're presented with information. So for example, so far, we've seen single sample t-tests, we've seen dependent means t-tests, we've seen independent means t-tests, 3 basic t-tests. And when we were doing or analyzing the experimental data from Harlow and Zimmerman's infant monkey studies, we did a single sample t-test. But we did that single sample t-test because we were in the first part of chapter 8. And it was a class about single sample t-tests. And I told you, let's do a single sample t-test. But in the real world, you're just going to be given the situation and data. So how do you decide that, oh, this situation calls for a single sample t-test? How do you know it's that one sample t-test? In the timeout condition, when we were taking a look at accuracies between subjects when they did a 5-second timeout condition and the same subjects when they did a 10-second timeout condition, we knew to do a dependent means t-test, once again, because we were in chapter 8, and that was the class on dependent means t-test. But how is it that you decide that in the real world when, again, all you're given is the situation? And then lastly, in the Loftus and Palmer study on memory and how it changes when subjects are asked how fast were the cars going when they hit each other versus how fast were the cars going when they smashed into each other. Once again, we were in chapter 9, so of course we were going to do an independent means t-test. But in the real world, we have to decide how can we make that determination with just the experimental description and the data. So that's what we're going to be doing today. So you got all the skills in order to do t-tests. Now we're going to be able to figure out how you can identify what is the correct t-test to do, which one of these in any situation is the one that you need to choose in order to analyze your data correctly. So we're going to see how to do that, and then we're going to see a very striking example of why that decision is so important. All right, so I'll give you a general guide right now for how to choose hypothesis tests, and then we're going to take a look at the importance of choosing the correct test, and then just wrap it up with a look at a reminder of the homework assignment. All right, so this is a general guide for choosing hypothesis tests. This is basically the procedure that I go through whenever I'm faced with an experiment. I need to analyze some data. How do I decide which one to do? So what the decision tree that I'm going to show you starts with is how many independent variables do we have? So I'm illustrating this because it does go a little bit beyond the scope of the course, but it's key to know whether you have 2 or more independent variables, 2 or more causes that you are manipulating and testing, or do you just have 1? If you have 2 or more, that is outside the scope of this course. I'm mentioning this now because I also do the advanced lab and I help students when they do statistics for the advanced lab. And oftentimes they will use experiments or design experiments with 2 or more independent variables because we are human beings and our characteristics tend to interact with each other. We have more than just one cause for the behavior that we do. So it's a very popular experimental design, and they oftentimes come to my office and very apologetically apologize for forgetting how to do this. I just want you to try to remember, we're not going to learn how to do this. This is beyond the scope of this course. So feel free to come by to my office when you're doing your advanced lab, if this is your design, and just ask me to show you now. I promise I will, and again, that is kind of like stats part 2, not what we're doing this semester. What we are doing this semester is we're dealing with analyses that have 1 independent variable, 1 cause. So the type of mother, that's the only cause we investigated. How did they phrase the question? That's the only cause we investigated. How long was the timeout? That's the only cause we investigated. So for for 1 independent variable, once you identify that you have 1 independent variable, the next thing you need to do is ask, how many levels are there in that variable? How many different values does that variable take? All right, so we have how many levels for that particular variable. And this again is in 2 different categories. The first one, you have 3 or more levels. We haven't encountered this yet, but we will see coming soon that the correct analysis for that is the ANOVA. So the ANOVA is coming up. That's going to be our final chapter that we look at. But 3 or more levels, we haven't gotten to that yet. We've been dealing with situations that have 2 levels. Independent variables that have 2 levels. So that is why we've been doing t-tests. Because the t-test is the correct hypothesis test for experiments where there are 2 levels. So we have tested between a terry cloth mother and a wire mesh mother. We didn't have a 3rd type of mother. We only had 2 types, 2 levels. We tested hit versus smashed into questions. We didn't have a 3rd type of question. It was just those 2. So 2 levels is what we've been dealing with. So for exam number 3, this is where you're going to start. You're going to start with knowing that you're doing a t-test. So this other stuff was kind of like a general way of choosing it. For your immediate exam though, we're doing a t-test. So now we have to figure out, how do we know which one of those 3 t-tests we're actually going to do? All right, so once you decide you're doing a t-test, next question to ask is, how many times is each subject measured? How many scores does each subject have? And each subject is either going to have 2 scores or they're going to have 1 score. If they have 2 scores, if they've been measured twice, then you do a dependent means t-test, you found your correct analysis, you're done. So if they were measured in the 5-second timeout condition, and then they were measured in the 10-second timeout condition, dependent means t-test. If the subjects were measured once before treatment, and then once again after treatment, dependent means t-test. If your subjects were measured twice, it's a dependent means t-test. On the other hand, sometimes your subjects are only measured once. If they're only measured once, the last thing you got to ask yourself is how many distinct samples are there in your experiment. So how many samples are there in the experiment? If there's only one sample, one group of subjects, and they were treated all the same way, then that is a single sample t-test, and you're done. So Harlow's monkeys were all measured once. How long did they spend with the terry cloth mother? And all of them were treated the same way. They all were exposed to the terry cloth mother and the wire mesh mother. They were one sample, all being treated the same way. On the other hand, sometimes you'll have an experiment with two samples. For example, the Loftus and Palmer experiment. Some of the subjects were asked how fast were the cars going when they hit each other. That's sample number one. Other subjects were asked how fast were the cars going when they smashed into each other. That's sample number two. Two different groups of individuals treated differently in the experiment. If you have two samples, then you're done. You're doing an independent means t-test. And that is how you decide between those three different t-tests. All right, so that's the overall kind of decision tree that you would go through in deciding for a hypothesis test. But you, right now, are going to be starting right here. So you can just start by taking a look at how many times is each subject measured. If it's two, you're done. You're doing a dependent means t-test. If they're only measured one time each, how many samples are there? If there's one, single sample t-test. If there's two different samples, we're doing an independent means t-test. All right, so any questions on that tree or that series of decisions? All right. Okay, so what we're going to do right now is we're going to take a look at the importance of choosing the correct test by doing a demo problem that can be done as a dependent means test and also can be done as an independent means test. So the first thing to kind of realize about the importance of choosing the correct test is that the data oftentimes will not do that for you. Oftentimes you'll be given data and without knowing the context or without knowing the description or the design of the experiment, it could be data from a dependent means t-test or it could be data from a dependent means t-test. So we need to be able to be sure that we identify which one is the correct one. All right, so the description we're going to be doing for the experiment is right here, so I'll read that off for you. Because people often forget names, but they believe that they never forget a face. Is memory for faces better than for names? A researcher tests 34 subjects. Half of the subjects are asked to memorize a series of 30 faces. Later they are tested with a recognition task for the faces. The other half of the subjects are asked to memorize a series of 30 names. Later they are tested with a recognition task for the names. There are your scores. Do the data indicate a significant difference? Use a one-tailed test with an alpha of 0.05. So we're doing one-tailed because we're testing whether faces are better remembered than names. So in this case, we're looking at this situation here, and we have subjects that are measured once. They memorize things, and then we see how well they recall those. So they're measured once, and then we have two distinct samples. We got one half of the subjects memorized faces. We got the other half of the subjects memorizing names. So subjects measured once, two distinct samples. That's an independent means t-test. The correct analysis for this data, for this situation, is an independent means t-test. So we have 17 subjects over here who memorized faces, and we have an additional different set of 17 subjects over here that memorized names. All right, so we've identified this as an independent means t-test. Now it's time to go through our 5-step hypothesis testing procedure. So step number 1, restate the question as a research hypothesis and a null hypothesis about the population. We want to know, do people have better memory for faces than for names? So our research hypothesis is that memory is better for faces, and we write that as the mean percent recall for faces is greater than the mean for remembering names. So that's the research hypothesis. Null hypothesis, complete opposite of that. Memory is not better for faces. The mean accuracy for faces is less than or equal to the mean accuracy for names. So that's the null and the research hypothesis. Step 2, determine the characteristics of the comparison distribution. SPSS is going to do this for us. Step 3, set a cutoff probability. We have a one-tail test with a cutoff probability of alpha. So it is a one-tail test with an alpha 0.05. So our cutoff probability is 0.05. We need to determine our sample score on the comparison distribution. We are changing this to determining your sample's probability on the comparison distribution. That's the p-value, and SPSS will do that as well. All right, so let's fire up SPSS. If you haven't already, sign into IU Anywhere, get SPSS rolling on your computer. The data for this can be found in on Canvas in the Excel sheet 09 practice June 12th, chapter 9, the t-test for independent means. There's the data right there. All right, so remember that we, because of the description, everybody is measured only once. They memorize something and then they're measured on how well they memorized it. Half of the subjects memorizing faces, half of the subjects memorizing names. We have an independent means t-test. And here we go. Okay, so if you're comfortable working ahead, feel free. If not, I'm going to go through the steps here. So first thing we want to do is we want to take our face memory scores and we pop that into SPSS, and we have to use, depending upon your browser and your Citrix access, we need to use this clipboard. Whoops. So we pop that into column number 1, and we can call that column memory to jog our own memory. And actually, let me jog my memory and see what I called it in. Oh. Okay, we'll call it memory. That'll be good enough. All right, so we got memory here, and then we also want to let SPSS know where these scores came from. So these were the face scores. So what we're going to do is in SPSS here, we are going to write face to identify each of these scores as belonging to the face group. And we're going to fill that all the way down. All right, and then go to variable view, and let's just call that group. All right, so now we have our memory scores from our memory subjects and the fact that they're in the face condition. All right, next one. We take our name scores from the subjects in the name group that memorize the names instead. And remember that they are separate subjects, so they get their own rows. So we will paste So we paste their scores directly underneath the original scores because they need their own rows, because one row to every single one subject to every single row, one row for every subject. We label those as name, and we can copy and paste that all the way down, and we have it set up correctly here. So we have memory scores for the face group, we got memory scores for the name group. We're now ready to do our analysis. So we go to Analyze, Compare Means. We decided we're doing an independent means t-test. So we go here to Independent Samples t-test. And we have our test variables for memory here. And we have our grouping variables. And we're going to define the groups. And the first group, let's call that face. Second group, we'll label it as name. Remember, make sure that the capitals are correct as well. And then we hit OK, and we get our output. So SPSS has run our t-test, and now we just need to know where to find that information so that we can do our final decision. All right, so we did our independent means t-test. So now we need to find out whether or not we're going to reject or accept the null hypothesis. And once again, we moved away from using cutoff scores to using cutoff probabilities. So if your p-value is less than your alpha value, we are going to accept the research hypothesis and reject the null hypothesis. If it's the other way around, where the p-value is less than, p-value is greater than alpha, we are going to accept the null hypothesis and reject the research hypothesis. So let's go through our analysis of this output so that we can see where the information is that we need for each step. So we need to find step 2, where we can find the degrees of freedom and the estimated standard error. We don't need step 3, that's our cutoff probability, that's alpha. That's 0.05. We do need step 4, which is our p-value, and we need to make a decision based on that information. First thing we want to do, go to that top table and check to make sure you entered your data correctly. When I was copying and pasting just now, I put in too many face people. I put too many people in the face group. I caught myself before I went to the analysis, but just in case I didn't, that would show up here as having 18 people in the face condition and 16 people in the name condition. That would be incorrect. It would warn me that I messed up somewhere. This is correct. We got 17 in each condition. That's what we're looking for. Gives us confidence that we entered it in correctly. We could also calculate the mean in Excel and compare it to the means that SPSS has calculated. Once again, just to make sure that our data entry has nothing's gone wrong with that. All right, so now we need to find step 2, step 3, and step 2 and step 4. We need that information. Remember that for the independent samples t-test, we are going to stay in the top row. We are going to stay in that equal variance is assumed row. And the first thing we're going to find is our degrees of freedom. SPSS lets us know that our comparison distribution has 32 degrees of freedom. And we need to find our estimated standard error. And notice we got standard errors up here. We got standard errors down here. There's 4 of them. So if you just randomly grab standard errors, you got a 1 in 4 chance of getting it right. You got a 75% chance of getting it wrong. So know the one you're looking for. It is that one right there. So it's 3.03. That is our standard error, our standard deviation for our comparison distribution. Our alpha is 0.05. Now we need to find our p-value. So for the p-value, it is calculated by finding out your sample's t-statistic. So by taking a look at the mean difference and comparing it to the standard deviation of the comparison distribution, that's how this t-statistic is calculated. So I'm pointing this out because your homework doesn't do it with the cutoff probabilities, it does it with the cutoff scores. So that is where you can find your sample's t-score when you're doing your homework using SPSS. So there's your sample t-score. That t-score directly determines your sample's probability, which is right there. So your sample's probability two-tailed is 0.388, right? We have a 38.8% chance of getting a sample this weird if faces and names are equally well remembered. However, we're not quite there because this is two-tailed. We're doing a one-tailed test. So we need to take that 0.388 and we need to divide it by 2, and that'll give us our final p-value of 0.194. All right, so we're doing a one-tailed test. SPSS gives you 2 tails, so you have to take those 2 tails and divide it by 2, throw one tail away if you're doing a one-tail test like we are right here. All right, so now we got to decide whether to reject the null hypothesis. If your p-value is less than your alpha, we would accept the research hypothesis, reject the null hypothesis. Our p-value is greater than our alpha, so we're not going to do this. We're going to do this. Our p-value is greater than alpha, so we're accepting the null hypothesis. Once again, that is all determined by our alpha level compared to our sample's probability, our p-value. So once again, the p-value correctly divided by 2 compared to the alpha, we accept the null hypothesis. And it turns out that based on this data, based on this research, memory for faces is no different than memory for names. There is no, we're not better at memory for faces. That's an illusion according to this analysis. All right, so people are not better at remembering faces than they are remembering names. All right, that was the independent means t-test. Now let's take a look at what happens if you do the other version of the test. If you do a dependent means t-test, importantly, with the exact same data. So let's say that this was the actual description for the experiment, right? Let's say that we read the wrong description for this experiment, and this was actually what took place. So, people often forget names, but they believe that they never forget a face. Is memory better for faces than for names? A researcher tests 17 subjects. The subjects are asked to memorize a series of 30 faces. Later, they are tested with a recognition task for the faces. The same subjects are also asked to memorize a series of 30 names. Later, they are tested with a recognition task for the names. So now we have 17 subjects measured once for faces, measured a second time for names. They are one sample measured twice. That is a dependent means t-test. So there are the scores, and the scores are exactly the same as we did in the previous example. The only difference here is that these 17 subjects over here are the same people as these 17 subjects over here. So subject number 1 here is the same person as subject number 1 here. Subject 5 over here, same person as subject 5 over here. Subject 16, same person as subject 16 over there. All the numbers are the same. All the data is the same. It's just that now it's come from a dependent means t-test. So do the data indicate a significant difference? Use a one-tail test with an alpha of 0.05. So remember that for the independent means t-test that we just did, we accepted the null hypothesis. All right, so keep that in mind. For the independent means t-test we just did, we accepted the null hypothesis. What now happens when we use the exact same data, but we run it as a dependent means t-test? Well, some things change. Some things don't. Most of it does. One thing that doesn't change is your null hypothesis and your research hypothesis. So step 1 stays the same. We still want to know, do people have better memory for faces than for names? And our research hypothesis is still that memory is better for faces, and that is still written as the mean recognition for faces is greater than the mean recognition for names. Null hypothesis is the complete opposite. Memory is not better for faces. The mean recognition for faces is less than or equal to the mean recognition for names. So that hasn't changed. What will change is step 2, determining the characteristics of the comparison distribution. That's going to be different. Step 3, that's not going to change. Set our cutoff probability. That is still alpha. That is still 0.05. So let me start setting up some of this info on this other part over here. So step 2 is going to change. Our degrees of freedom are going to change. Our standard deviation of our comparison distribution is going to change. Alpha level does not change. Still 0.05. Step 4, our probability for a sample, that is going to change as well. So SPSS will still do that. It'll calculate out our sample's probability. So let's go back to SPSS And again, it's the same exact data that we were using before, but this time we have to set it up for a dependent means t-test. All right. So for our dependent means t-test, let's go back to SPSS. Let's close out this previous output. Whoops. Let's close out this previous output. And whenever I'm done with the hypothesis test, I just like to clear the columns as well so that I don't get confused. So if that helps you out, feel free to do that. So this time, we're going to take our face recognition scores. And once again, we're going to copy them into row 1, column 1, because that is where they need to go. So we paste those into row 1, column 1, and that's face data, so let's call that faces. And there we have it. Now we need to put in the name recognition scores. And for the name recognition scores, this time, because they are coming from the same subjects, they are scores from the same subjects, they need to be placed in the same rows as the previous scores. So subject number 1 only gets row number 1. That's the only row that subject number 1 has access to. So subject number 1's name score also has to go in row number 1. So we go to column number 2 and paste those scores directly beside their original scores. We go to the variable view, and let's call this name so that we don't get confused. So now we got our face scores, and we have our name scores, and now we are ready to do our analysis. So we go to Analyze, Compare Means. We decided it's a dependent means t-test based on the description, so we're doing a paired samples t-test. That's what SPSS calls the dependent t-test. And we are going to pop in faces as variable number 1. Let's pop in name as variable number 2. And we hit OK. And we get our analysis. And we notice down here that this is face recognition minus name recognition, which gives us a positive value if faces are better recognized. And that makes more sense to our human mind. So I'm going to keep it in that position. And let's finish up our analysis. So we have our output. So now we have to figure out our information here so that we can decide whether or not to reject or accept the null hypothesis. Once again, at the probability, if the p-value, our sample's probability is less than our alpha level, our cutoff scores, we're going to accept the research hypothesis, we're going to reject the null hypothesis. If the opposite is true, we are going to accept the null hypothesis and reject the research hypothesis. So we go to our table here. Let's see what information we have. First off, always double check this section up here. So SPSS has calculated out the means, same means that we calculated in Excel, or we could calculate in Excel. So that gives us confidence we entered it in correctly. SPSS lets us know it's got 17 scores. In each condition, we have 17 subjects. So that, once again, is the correct number to have. And now we go down to the paired samples test over here. We need to find the standard deviation of the comparison distribution. There it is right there. So notice, this is one of the first things that is different. Standard deviation is no longer 3.03. Now it's 0.546. And we need to find our degrees of freedom. Degrees of freedom no longer 32. Now we got half the degrees of freedom. We only have 16 degrees of freedom. Alpha level is 0.05. Now we need to find the p-value, the probability of our sample. Notice that the mean difference is still the same, right? It's the same data. The difference between the two means for the two conditions is still exactly the same. But now, because our standard error is so much smaller, our t-statistic becomes 4.85. And that t-statistic is directly tied into this sample probability right there. So the probability of this sample is actually too small for SPSS to display. So we're just going to go with what they displayed, 0.000. That's your two-tailed probability. You got to take that and divide it by 2, and that gives you the probability of, same, 0.00 is the same probability. But make sure that you are doing that correctly. In this case, it's a one-tailed test. SPSS gives us two-tailed. We got to divide that probability by 2. And now it is decision time. So what do? If the p-value is less than our alpha, that p-value is less than our alpha, we accept the research hypothesis and we reject the null hypothesis. So we are going to accept the research hypothesis. If it was the other case, we would reject the research hypothesis, accept the null hypothesis. But because our significance, our one-tailed p-value is less than our alpha, we reject the null hypothesis and we conclude that people actually are better at remembering faces than they are at remembering names. And look at the difference here. We had the same data, the exact same data, and when we analyzed it as a dependent means test, we ended up accepting the null hypothesis. Well, sorry, accepting the research hypothesis. When we analyzed it as an independent means t-test, we made the opposite conclusion. We accepted it as, we accepted the null hypothesis. So in one analysis, we concluded there is a difference. In the other analysis, we concluded that there is no difference. So that illustrates the importance of choosing the correct test. If you choose the wrong test, you could get a completely different answer. Statistics requires that you use the correct analysis in your test, and that's why we need to make sure that we're choosing the correct test when we do our analysis. All right, so that was it for the first part here. So what we're going to do right now, we're going to take a 15-minute break. We're going to start off class again at 10:30. Just a couple of things to mention. Number one, your MyStat Lab study plan, mastery points for chapters 6, 8, and 9. Those are due June 16th at 11:59 p.m. That is the midnight before the day of the exam. I have already posted and used in your calculation of your projected grade your pretest scores for chapter 6, 8, and 9. Once you complete your mastery points, I will update those. So your projected grade can go up right now if you complete your mastery points. Right now, 6, 8, and 9, I calculated those without the mastery points because the mastery points weren't due yet. So just be aware that if your projected grade isn't quite where you want it to be, you can grab yourself points towards your pretest by completing those mastery points and earning 100% on those 3 pretests. All right, and do remember that homework assignment number 12, chapter 9, is due June 14th at 12:15 p.m. So a little bit of weirdness because of the exam that's coming up. But you are ready to go. You got all the tools that you need for the chapter 9 homework. And the chapter 9 post-test is, again, a little bit of weirdness, due June 16th at 12:15 p.m. So please be aware of those. Don't miss those due dates. And max out your points for doing the work that you're doing. Other than that, that's what I wanted to cover for this first part. So we're going to take a 15-minute break. We'll resume class at 10:30. And this is it for exam number 3. This is where exam number 3 ends. Because it's a summer session, we're going to have to keep on going with the class. But right now is where exam 3 ends, so use that in consideration when you're preparing. Other than that, let's take a break.